Algebra 2, Chapter 5, Section A, Review. Number 1. f of x equals x minus 3 squared. Describe the transformations. So this has to go all the way back to our Chapter 2, talking about transformations. I ask you guys to remember x minus. So whatever that x subtracting the number, if it's positive, then you move right. In this case, we have x minus 3, x subtracting positive 3. So that means everything is being moved right 3 units. Right 3 units. And in fact, this is in vertex form. So we can identify the vertex as well. Right 3 unit. So meaning that from the original point 0, 0, the whole thing is being moved right 3. So 0, 0 being moved right 3. I'm only moving right, horizontally right 3 units. From there, you can definitely plug it in the points to help you make the graph. So for me, I'll just do right 1 up 1, right 2 up 4. Left 1 up 1, left 2 up 4 to help me make the graph. You can have more points, but these are the basic 4 points, 5 points. Let me redo the graph again. It looks like it's way off. So as I connect the 5 points, you should have something like this, right 3 units. And as you can see, the vertex is being moved right 3 units. Number 2, f of x equals x plus 4 squared plus 1. This one, I would like to rewrite it as f of x equals x minus negative 4. I like to keep it in the same form, x subtract something. So this time x is subtracting negative 4. So negative 4 is a negative number. So it's being moved left 4 units. And then the plus 1 is outside of your quadratic. So this is telling you it's going to move up 1 unit. So left 4, up 1. Where's our vertex? Where is our vertex? It's going to be located at negative 1, 4, 1. So from negative 4, 1, I use the same points I used. Right 1 up 1, right 2 up 4, left 1 up 1. Let me erase that point. Left 1 up 1, left 2 up 4. So notice I always start from my vertex point, and that's the whole idea of transformation. I start from my vertex point. So I identify my vertex point first. By the way, for the first one, I forgot to write down the number. The vertex should be located at 0, 3. Number 3, f of x equals negative 2x squared plus 3. So the first question come to you is, so where's my h? X is not subtracting anything. I'm glad you noticed that. X is not subtracting anything. So what would be the logical way for you to explain? So the only number that doesn't affect the function would be if x is subtracting 0. Subtracting 0 means that we are not moving left or right. So subtracting 0 means that it does not move left or right. Plus 3, so this is going to tell us the whole function is being moved up by 3. How about negative 2? Negative 2 means we have a vertical stretch factor of 2, and then the negative means that it's being reflected across the x-axis. So being reflected down, or you can think of it has a sad face. It has a sad face. So where's our vertex? Vertex is located at 0, 3. So locate your 0, 3. Actually, that's going to be our y-intercept point, 0, 3. Vertically stretched by 2. So I go right 1, I go down 2. I go right 2, I go down 4 times 2, which is 8. Left 1 down 2, left 2 down 8. So the vertex point tells us it's being moved up by 3 units. There was no horizontal shift left or right because we are subtracting 0. and then the vertical stretched factor of 2 reflected across the x-axis. Question number 9. Solve by completing the square. Solve by completing the square. So we just practiced this. How do I do this problem? So first I like to complete the square for the quadratic and the linear term. So I'm going to subtract 12 to both sides of the equal sign. So I mentioned this over and over. This is an equation. Whatever you do to one side, make sure you do it to the other side of the equal sign. So the side means across the equal sign. So I subtract 12, then I have to subtract 12 to the right hand side. I'm only completing the square for the quadratic and the linear. And what would be the number I have to add here to complete the square? So remember I said if your leading coefficient is 1, simply take the linear term coefficient, which is 8, divided by 2, then square it. So 8 divided by 2, that's 4. 4 squared is 16. So do you notice that I add 16 to the left hand side? So I have to add 16 to the right hand side. So I mentioned that the equal sign in this case is like a scale. So make sure you add across the same thing to both sides. X squared plus 8x plus 16. So if you know your factoring very well, can I write it as x plus 4 times x plus 4? And x plus 4 times x plus 4 equals, so negative 12 plus 16, which is 4. I can write x plus 4 times x plus 4 as x plus 4 squared equals 4. So square equals a number. How do I figure out the x value? I'm going to take the square root on both sides. So I have x plus 4. Take the square root on both sides. And I mentioned this several times. Make sure you put on positive and negative. Square root and square, they cancel each other. So on the left hand side, I'm left with x plus 4. Square root of 4 is 2. So my answer is going to be positive 2 minus 4 and negative 2 minus 4. So 2 minus 4, that's negative 2. Negative 2 minus 4, that's negative 6. So my two answers for this number 9 is going to be negative 2 and negative 6. You definitely want to plug the numbers back into the equation to check whether it will make the equation equal to 0 or not. So don't forget to do your check part. Number 10. So the constant is already on the right hand side. So all I have to do is complete the square for the left hand side. So x squared minus 6x, what's the number I have to add to complete the square? So leading coefficient is 1. So take the number for the linear term coefficient. Negative 6 divided by 2 and square it, which is 9. I add 9 to the left hand side, so I have to add 9 to the right hand side. X squared minus 6x plus 9. I can write it as x minus 3 times x minus 3 equals, so 7 plus 9, which is 16. X minus 3 times x minus 3 can be written as x minus 3 squared equals 16. So follow the same procedure as before. Take the square root on both sides. Add positive or negative sign to the right hand side as you take the square root. So square root and square, they cancel each other. X minus 3 equals positive or negative. The square root of 16 is positive 4. So our answer to this one is going to be 4 plus 3, negative 4 minus 3. So that is 7 and negative 1. 7 and negative 1 for question number 10. Again, make sure you practice the completing square. It is crucial for you to do complete the square in this chapter. Number 11. solve by quadratic formulas. So what's quadratic formula? X equals negative b plus or minus square root of b squared minus 4ac, the whole thing, okay, the whole thing on top divided by 2a. When you plug it in quadratic formula, please do not think too much other than identifying the parameter values of a, b, c. The next step would be plug in the numbers. So take a look at number 11. What's our a value, b value, c value? So these are the parameters that we are looking for. So we have a is going to be the leading coefficient, which is 2. B is going to be the linear term coefficient, which is negative 4. C is the constant, that's negative 1. So plug it in once you have the value, okay? So we have the denominator is 2 times a, so a is positive 2. At the numerator, we have minus b, so don't forget your negative sign, minus b, and b is a negative number, so I like to put a parentheses. Plus or minus, the b squared is, so negative 4 squared, so negative 4 gets squared, minus 4 times a times c, so again c is a negative number, so put a parentheses. And then the next few step is calculate. 2 times 2, I have 4. Minus negative 4, so that's positive 4. Plus or minus, so negative 4 squared is going to be 16. Negative 4 times 2, that's negative 8. Negative 8 times negative 1, that's positive 8. Then simplify, reduce if you can. So we have 4 plus or minus square root of 16 plus 8. 16 plus 8, we have 24. So is there any perfect square with 24? So I know 24 is 4 times 6, and 4 is a perfect square, so I can factor it out. Let me write it out so that I know exactly what I'm doing. So 24 is 4 times 6. So notice that square root of 4, I'm looking for the perfect square inside the square root. So square root of 4 is positive 2. So this is what I meant about taking it out to the outside of the square root. So now the common factor 4, 2, and 4. The common factor is 2. So I can reduce top and bottom. I divide top and bottom by 2. 4 divided by 2, I have 2. 4 divided by 2, again I have 2. 2 root 6 divided by 2, that's root 6. So this should be my final answer for number 11. Number 12, what are the A, B, C parameter values? So I have A equals 1, B equals negative 3, and then C equals negative 6. Plug it in. So I have X equal 2A, 2 times A, which is 1, minus B, which is negative 3B, so minus negative 3. Don't forget your negative sign. Negative B squared, negative B, so B squared, minus 4 times A times C. Like I said, once you identify the A, B, C parameter values, all you have to do is plug the number in. So 2 times 1, I have 2, minus negative 3, so that's positive 3, plus or minus negative 3 squared, which is 9. Negative 4 times 1, that's negative 4. Negative 4 times negative 6, that's positive 24. So what we have inside the square root, the radical expression, square root, 9 plus 24, which is 33. And 33, there are no more perfect square numbers. So that should be our final answer. X equals 3 plus or minus the square root of 33 over 2. Again, once after you've identified the value for A, B, C parameter values, all you have to do with quadratic formula is plug it in. Question number 13. You are asked to graph the quadratic functions. F of x equals x squared minus 4x plus 3. So first thing I would like to rewrite this into vertex form. So whenever it comes to vertex form, remember in our lesson I said vertex form is the same as completing the square concept. So how do I do a complete square? Again, I'm just looking for the quadratic and the linear term. Quadratic is x squared minus 4x. So what should be the number I have to add to complete the square? X squared minus 4x. So I take the negative 4 divided by 2 and square it. Negative 4 divided by 2, that's negative 2. Negative 2 squared, that's positive 4. So I add 4. I borrow 4. I have to give it right back. Subtract 4 right away. Okay? So make sure you borrow 4, subtract 4 right away. Then I can rewrite these three terms. X squared minus 4x plus 4 into perfect square form, which is x minus 2 squared. 3 minus 4, which is negative 1. So rewriting into vertex form, I have x minus 2 squared minus 1. That means my vertex is going to be 2, negative 1. 2, negative 1. 2, negative 1. How about the y-intercept? Y-intercept is by setting your x equals 0. So if I put the 0 all the way back to the given equation, x squared minus 4x. So both of them will be 0. I'm left with just a constant, 0, 3. X-intercept. X-intercept is by setting the function equal to 0 and then solve for the x. X squared minus 4x plus 3 equals 0. So this looks like I can use a factoring fish method. I'm looking for two numbers. When you multiply together, you have positive 3. And when you add these two numbers, you have negative 4. So I think it's going to be negative 3, negative 1. So the factor form for x squared minus 4x plus 3 is x minus 3 times x minus 1. If you need to draw the factoring fish, the square, to help you visualize it, definitely put it down. Set each of your factors equal to 0. X minus 3 equals 0. X minus 1 equal to 0. Solve for the x. So I have x equal to 3. X equal to 1. 3, 0, and 1, 0. Mark this on your graph. So now we have the vertex located at 2, negative 1. We have the x-intercept located at 1, 0, 3, 0. We have the y-intercept located at 0, 3. All this information put together, draw the quadratic equations passing through all these points. So your graph should look like this. Number 14. F of x equals x plus 3 squared minus 4. It's already in the vertex form, so we can identify the vertex as, so make sure you write it as x minus negative 3. So vertex is going to be negative 3, negative 4. Y-intercept, so y-intercept is by plugging in x equals 0. So since this is a vertex form, I have to calculate it myself. 0 plus 3 squared, which is 9. 9 minus 4, that's 5. So y-intercept is going to be 0, 5. How about x-intercept? X-intercept is by setting the function equal to 0. So x plus 3 squared minus 4 equals 0. So my x is going to be negative 1, negative 5. Again, we have the vertex located at negative 3, negative 4. We have the y-intercept located at 0, 5. And the x-intercept negative 1, 0, negative 5, 0. With all these points, connect the dots with a graph. So your graph should look like the one I have up here. Question number 15. List 4 characteristics of the quadratic, then write the equations. So what would be the most distinctive characteristic when you observe this graph? So I notice that it's an opening down parabola. It looks like a sad face opening down. So once I identify that, I know my A. So my leading coefficient should be a negative number. Next, I notice that the graph is crossing the x-axis at 0, 0, negative 4, 0. So these are my x-intercept. followed by y-intercept. What's our y-intercept? Where does the graph cross the y-axis? So it happens to be located at 0, 0 as well. So both 0, 0 is the x-intercept and the y-intercept. How about the vertex? So we identify it's an opening down. Can you read out the vertex value? So vertex is going to be located at -2, 4. With all this information, do you think you can write out the equations? So the function equation I have is f of x equals negative, because it's an opening down, x minus -2. Vertex is located at -2. So x minus -2 become x plus 2 squared plus 4. It's being shifted up 4 units. And this concludes our Chapter 5, Section A review. Take a look at the questions. Ask me any questions you may have. Study it, practice it. The 4 methods that we discussed so far with the factorings: special factorings, completing the square,